Let's look at the NPN transistor. Transistor has 3 pins: the emitter, aka the output, the base, which controls whether or not electricity flows through the transistor, and the collector, aka the input. We show a transistor on a schematic using this symbol: C for collector, B for base, and E for emitter. We use transistors to create logic gates, which I have a series on if you want to know what those are. But how does a transistor work? Transistors use semiconductors, the most common of which being silicon. And silicon has 4 electrons in its valence shell, aka its outermost electron shell. However, due to the octet rule, most atoms want to have 8 electrons in this shell, meaning that silicon will bond with its nearest 4 neighbors to create a silicon crystal, which gives it 8 electrons in its valence shell. As we can see here, it has 8. However, the magic of semiconductors is when we use doping. There are 2 types of doping, the first of which is called N-doping, and this is where we switch some of the silicon with the atom with 5 electrons in the valence shell, the most common being phosphorus. As you can see here, this phosphorus has 9 electrons in its valence shell, meaning that one of these electrons, specifically this extra one, is going to pop out and have a negative charge. Remember this will come in handy later. The next type of doping is called p-doping, and for p-doping we will use an atom that has 3 electrons in its valence shell. Let's use aluminum. As you can see here, when aluminum combines with the 4 silicon, it's missing an electron. And this means that whenever an electron passes by, the aluminum will try and take it in to fill its valence shell. Well, an NPN transistor is exactly like its name sounds. Some n-doped silicon, p-doped silicon, and then more n-doped silicon. And we can attach our 3 pins: the emitter, the base, and the collector. Now, remember those extra electrons floating around in the n-doped silicon? Well, those are going to travel into the p-doped silicon to fill those holes. However, this makes the atoms in the p-doped silicon negatively charged, creating a barrier that will not let any more electrons travel in, as it will repel the other negative charges. This is called the depletion layer. However, when we apply a positive charge to the base, it eradicates this depletion layer, allowing the flow of electrons through the transistor. And if you didn't know, electricity goes the opposite way of the electrons, allowing our electricity to flow through our collector to our emitter only when the base is on. And there you have it. That is the NPN transistor.